For years, artificial intelligence was almost synonymous with the cloud. Smart features meant data being sent to distant servers, processed at scale, and returned with an answer. That model shaped everything from voice assistants to photo recognition. But something important is changing inside US tech companies. More and more AI features are being designed to work without the cloud at all. Offline AI, once considered limited or impractical, is now a major strategic focus. And this shift reveals how priorities around performance, privacy, cost, and reliability are evolving across the US tech industry. Offline AI refers to artificial intelligence tasks that run directly on a device rather than relying on internet-connected servers. This includes smartphones, laptops, tablets, wearables, and even home devices. Instead of sending data out for processing, the device handles it locally using built-in hardware and software. While cloud-based AI is still important, US tech brands are deliberately shifting more intelligence onto the device itself. One of the biggest reasons for this shift is speed. Cloud-based AI depends on network quality, latency, and server availability. Even with fast connections, delays are unavoidable. Offline AI runs instantly. Tasks like voice recognition, image processing, text prediction, and system optimization happen in real time. As users expect devices to respond immediately, relying on the cloud becomes a bottleneck rather than a benefit. Reliability is closely tied to this issue. Cloud-dependent features stop working when connectivity is weak or unavailable. Offline AI works anywhere. Whether a user is traveling, underground, in airplane mode, or in areas with limited coverage, AI features continue to function. For US tech brands focused on delivering consistent user experiences, this reliability is critical. Devices that fail when the network fails feel fragile in a world that expects constant availability. Privacy concerns are another major driver pushing AI away from the cloud. US consumers are increasingly aware of how personal data is collected, transmitted, and stored. Cloud-based AI often requires sending sensitive information such as voice recordings, images, location data, or usage patterns to remote servers. Offline AI keeps that data on the device. This reduces exposure to breaches, misuse, and regulatory risk. As privacy expectations rise, on-device processing becomes a competitive advantage rather than a limitation. Regulatory pressure reinforces this trend. Data protection rules are becoming stricter, and compliance is more complex when data crosses networks or borders. Offline AI simplifies compliance by minimizing data movement. For US tech brands operating at scale, reducing regulatory complexity is not just a legal concern but a business one. Designing AI features that work without constant data transmission lowers long-term risk. Cost structure is another powerful incentive. Cloud-based AI is expensive to operate. Every AI request processed in the cloud consumes computing power, energy, and infrastructure. As AI features become part of everyday device usage, those costs add up quickly. Offline AI shifts much of that workload to the device itself. While this requires investment in hardware and software up front, it reduces ongoing cloud expenses. Over time, this shift can significantly improve margins for tech companies. Hardware evolution has made offline AI viable at scale. Modern devices now include dedicated AI accelerators, neural engines, and specialized chips designed specifically for machine learning tasks. These components can run complex models efficiently without draining battery life. What was once only possible in large data centers can now happen in the palm of a user's hand. As this hardware becomes standard, designing AI features that require the cloud becomes less necessary. Battery efficiency also benefits from offline AI. Sending data back and forth between a device and the cloud consumes power. Local processing is often faster and more energy efficient, especially for repetitive tasks. Offline AI allows devices to deliver intelligent features while preserving battery life. In consumer technology, where endurance remains a top concern, this efficiency matters. Another reason US tech brands are focusing on offline AI is user trust. When features depend heavily on the cloud, users may worry about surveillance, data retention, or unintended use. Offline AI is easier to explain and justify. Your data stays on your device is a simple and powerful message. In an environment where trust is fragile, that clarity is valuable. Offline AI also improves responsiveness for accessibility features. Tools like live captions, voice control, predictive typing, and assistive interfaces work best when they respond instantly efficiently. Delays can make these features frustrating or unusable. Running them locally ensures they remain fast and dependable. This expands access and improves usability without requiring constant connectivity. Security is another area where offline AI shines. On-device AI can monitor behavior, detect anomalies, and respond to threats in real time. Because it operates continuously and locally, it can act faster than cloud-based systems. This makes devices more resilient against evolving threats. For U.S. tech brands facing increasing security expectations, embedding intelligence directly into devices strengthens overall protection. Offline AI also changes how software is designed. Developers can build applications that assume constant access to AI capabilities without worrying about network conditions. This leads to simpler architectures, fewer failure points, and more predictable behavior. As more apps are built around local intelligence, offline AI becomes the default rather than the exception. Importantly, this shift does not mean the cloud is disappearing. Cloud-based AI is still essential for large-scale training, updates, and complex tasks. What is changing is the balance. Training and coordination happen in the cloud, while execution increasingly happens on the device. This hybrid model combines the strengths of both approaches. Competition among U.S. tech brands accelerates this focus. Once one major company demonstrates the benefits of offline AI, others must match or exceed those capabilities. As a result, offline AI is rapidly moving from premium devices into mainstream products. What once felt like an advanced feature is becoming an expectation. There is also a strategic dimension to this shift. By reducing dependence on cloud infrastructure, companies gain more control over performance, differentiation, and user experience. Offline AI allows tighter integration between hardware and software, which is a hallmark of successful U.S. tech brands. This control supports long-term innovation rather than reliance on external platforms. What makes the rise of offline AI notable is how quiet it is. Users rarely see a label saying offline AI enabled. They simply notice that features work faster, more reliably, and with fewer privacy concerns. This quiet improvement builds loyalty and raises expectations without requiring constant explanation. Looking ahead, offline AI is likely to become the foundation for many everyday features. As models become more efficient and hardware continues to improve, more intelligence will live directly on devices. The cloud will support and coordinate, but not dominate, everyday AI interactions. In the end, U.S. tech brands are focusing on AI without the cloud because it solves real problems. It improves speed, reliability, privacy, efficiency, and trust. Offline AI is not a step backward from powerful cloud systems. It is a step towards smarter, more resilient technology that works wherever users are. And that is why offline AI is becoming one of the most important and least flashy shifts in modern consumer technology.